Okay, well, let's get started. Hi, everybody. I'm Ash. I'm a Canadian iOS developer. I've been doing iOS for about 5 years now. I regularly blog about the topic, and I've written 4 books to date on it. Currently, I'm working at Artsy, which is a New York City startup. I'll talk a little bit about that later. What I want to talk about now is something that we had started to consider back in August. We had a need to develop a new iOS application, and Swift had been out for a couple months, and we thought, the Swift thing looks pretty cool. Let's try it, because what's the worst that could happen? Well, lots of things. So today we're going to talk about 5 main points. First, we're going to talk about why Swift was needed, because I want to go through the history of Objective-C, which is the language that Swift replaced, and talk about why it was necessary to replace Swift. Second, I want to talk about how Swift met or failed to meet those needs. Third, how writing Swift is really great, mostly. Fourth, using Swift in production. That's a little bit about our story of actually having used Swift to write an application. And finally, the future of Swift, where I'll try and make some predictions. Just to get an idea of your familiarity with Swift, has anyone written any Swift before? Just kind of played around with it? Okay. Oh wow, so about half, great. Awesome. Okay, so let's go on. So the first thing I want to discuss is why Swift was needed, and this is really, I mean, in hindsight, it's kind of obvious because it happened, but at the time, a lot of iOS people didn't think that Objective-C was that bad, and in fact, it was pretty bad. So I want to talk a little bit about Objective-C, its history, where it came from, where it was when it was replaced. It started in the early 1980s. Steve Jobs pushed out from Apple, started a company to make educational hardware and software called Next Step. And originally, Objective-C was a preprocessor for the C language, which was really nice at the time. Object-oriented programming was just starting to take off. And anything that they could do to make object-oriented programming feel as familiar as possible would help developers actually start using that language. So then it was a really big advantage to just be a C preprocessor. Takes stuff, turns it into C, and then you compile that like you normally would. Now, in 2015, that's a burden. Objective-C enjoyed moderate use until about the mid-2000s. Mostly used to make OS X applications at that point. And then the iPhone happened, and if we look at the size of the Objective-C community, we can see just after the App Store launched, boom, straight through the roof, which is pretty remarkable considering that the language was relatively stable for like 30 years. So we had a sudden interest in Objective-C, and this is despite what I consider to be esoteric syntax, and I won't let anyone convince me otherwise. An unusual memory management system, not like C where you have free and malloc, not like C++ where you have new and delete, not like Java where you have a garbage collector, but something in between, which is really weird. And it had a lot of arcane knowledge that was really locked up in the heads of these developers who had been doing Objective-C for decades. And so in the community after the iPhone launch, 3 distinct groups of software developers started to emerge. This isn't an idea that I had. This is an idea I'm borrowing from Matt Thompson, who's an Objective-C developer, or an iOS developer, I guess. We basically have first wave developers from the 80s and the 90s, people who've been doing this before Objective-C was a language on the Mac, back when it was the Next Step days. You had the second wave of Objective-C developers, OS X developers from the 2000s. After OS X came out in 2001, you had a niche market for Mac apps, and they started to fill that market. And the first wave of developers weren't really that happy about it, but the weirdness of Objective-C kept enough people out of their community that they were pretty happy with the way things were going. And the third wave of developers attracted by the gold rush of iPhone applications and the prospect of making fat stacks of cash on the App Store. And there are a lot of them, as we saw on that slide. Most of them came from an existing background. They weren't first-time software developers. They had written Java before, C# or Ruby or PHP, any number of different languages. And when you had all these developers interacting with each other, not just in terms of asking Apple for things like I want you to make Objective-C better, or I want you to keep Objective-C the same, you get a lot of friction. And this was kind of building up and is still kind of building up, I feel, since about 2008. So you've got tension between the individual developers and the groups of developers that are trying to work together. You have disenfranchisement because developers are asking Apple, please make Objective-C better, and Apple's not doing it enough. Or you have Apple who is making it better in ways that first and second wave developers don't really like. And so you get resentment towards each other, towards Apple. It's not really good. And it's not just in terms of the syntax of the language, it's also about the community. Because when you come from a background like Ruby, where it's really easy to distribute your own open source code, you're writing on a platform that is itself open source, coming to Objective-C where everything is very closed, there's just naturally going to be different ways of thinking about how software developing communities are supposed to form. So that's some background on the community. If we look at the actual progression of programming languages in general, it's pretty clear. Like over the past 80, oh my goodness, more than that, I guess, years, since we started computing things in general, we started with machine code where you would enter in bytes into the computer, and that's awful, terrible. I would never do that. If that was how you had to program, I wouldn't do it. I'd do something else. We invented assembly, so you could have English words that would be translated into machine code. And so you didn't have to remember that, OX63B4 is the instruction for jump. You could just type the word jump, and that's a lot better. After assembly, we invented high-level languages like C. Procedural languages that were able to basically write an application in a language that isn't tied to a specific architecture. When C came out, it was called portable assembly, which is, I think, really interesting. And after C, we got into object-oriented programming. I mean, this was a really new idea at the time. It's very obvious now, but object-oriented programming really frees us from having to write everything ourselves from scratch every time. All of a sudden, we have objects that can be reused across different applications and different types of applications. And at the time, people who were thinking very far ahead were saying, objects don't even need to live on the same computer. I can have an object on my computer, you can have a different object on your computer, and we can send messages to one another over the network. And that's how we can reason about these things. And that never really caught on, but that's, I don't know, I think that's a shame. And finally, we have virtual machines, which are sort of the state-of-the-art language right now. Java, C#, Ruby, all those ones. So there's a very clear progression from no abstraction and very, very complex programming to very, very high abstraction, very simple programming. And there's this quote from an Apple blogger, I guess you call him. He's been watching Apple for a very long time, and he was a big proponent of the need to replace Objective-C, and he said, while hardware performance increases over time, the human capacity to deal with complexity does not. And so hardware is going to keep getting faster and faster, and we can project that, eventually it's, object-oriented languages, virtual machines. What's next? There's something next. It's going to happen. With enough time, we're going to invent some new way to program if our species doesn't self-destruct. It will happen. But Objective-C is very firmly stuck where it was. And around 2006, you did start to see Apple develop some new features for Objective-C. dot property syntax in 2006, closures in 2009, decreased boilerplate and headers. Header files went from this long down to 2 lines of code. Automatic reference counting, which was supposed to be a great solution for the weird memory management issue. Collection literals, so you could define arrays with syntactic sugar instead of defining them as a regular class instantiation, and primitive boxing syntax, so you could box up like numbers into classes really easily. And all this was like stuff that Java had for years, and Objective-C developers got it, and they said, see, Objective-C is not so bad, it's getting better, we don't need to replace it. And that's categorically false, because these sorts of incremental changes and improvements are fantastic, and I really appreciated them at the time, but eventually we're going to get to that next step beyond virtual machines. And eventually, writing Objective-C is going to seem as archaic as writing assembler is today. And that would be a competitive disadvantage for Apple to rely on. And to say eventually, it's a pretty big word, pretty loaded word, really. I could be talking about 5 years from now, I could be talking about 10 years from now, 20 years from now, but eventually it will happen. It's just a matter of when you think that will happen. We see the progression of abstraction, we see its inevitability, it's only a matter of time. The problem with keeping Objective-C was that replacing your homegrown programming language takes decades. This is something that Microsoft has been working with on .NET for a very long time. They're still working on it. People are still writing 132 applications. It's ridiculous. So we have this language, Objective-C. It can't escape its C roots. Objective-C is a strict superset of C. So anything that you can do in C, you can also do in Objective-C. And it must maintain that backwards compatibility for technical reasons. Apple began working on Swift in 2010, and in fact, if we ask the developers of Swift on the Apple developer blogs, we find out that Objective-C only really improved because of the development that they were working on Swift, and that the improvements to Objective-C only happened as a side effect of creating Swift. So, an Objective-C replacement has some criteria that John Siracusa came up with originally. I've sort of pared it down a little bit. Basically, an Objective-C replacement would have to abandon all C roots. No header files, no malloc, nothing. Must be memory managed, no more of this retain release garbage. Have native Unicode strings and collections. It has to be concise and has to have named parameters. And Swift met those needs, mostly. It was announced in 2014, June. I was there. The Apple exec, Craig Federighi, was very excited on stage. They released a series of betas over the summer until the 1.0 in the autumn. Wasn't what I would call 1.0, but it was released, and we used it. Apple tried to market it as Objective-C without the C, which is a huge mischaracterization, in my opinion. Chris Latner, one of the developers behind Swift on the developer forum, said that calling it Objective-C without the C implies that Swift is subtractive, that they only took Objective-C, took away the bad parts, and then what was left over was Swift. But in fact, Swift added a bunch of new things, and we're going to take a look at a few examples shortly. So let's look back at our criteria for a successful Objective-C replacement. Did Swift abandon all C roots? Kinda. Is it memory managed? Kinda. But it does have native Unicode strings, native collections, it's concise, and it has named parameters. So let's go over each one of these points. The thing with Swift is that in order to get developers to use it, it has to be interoperable with Objective-C, which means it has to be interoperable with C. That's kind of frustrating. It is possible to interact with C APIs using Swift. It's very ugly. I would not recommend it. If you need to use a C API, I would suggest writing a wrapper in either Objective-C or Swift, and then confining that C ugliness to the smallest part of your application as you can. In terms of memory management, Objective-C has this weird thing called automatic reference counting. I mentioned it earlier. It was released in 2011, and basically it replaced garbage collection on the OS X platform, which angered a lot of people because garbage collection was only a few years old when they replaced it. and it replaced manual memory management on iOS and OS X. And basically, ARC, or automatic reference counting, is the same as doing things manually, telling objects when they're supposed to stick around, when they're supposed to go away, but it's inserted for the developer at compile time. And it's reasoned about by the compiler, which means that it can be optimized. And if you name your methods according to Objective-C conventions, then you get this for free. And it's very, very impressive as a technology. I'm impressed by it. The slide that Apple likes to use is something like this. We've got the manual code on the left, really, really big. And you've got the automatic code on the right. So the time it takes you to develop an application is way shorter. And more importantly, memory management is one of those things that you really have to get perfect. A small mistake leads to a memory leak that will eventually cause your app to be killed by the OS, or it'll cause a null pointer dereference and your app will crash. So, you know, our criteria was that Swift had to be memory managed. We got Arc. It's familiar, it's stable, there's no garbage collector, process running on another thread. The UI never locks up to collect memory. But it can't detect reference cycles, which is really important. So there's an added complexity that developers need to maintain from Objective-C into Swift. So what's our next criteria? Unicode strings. This is actually something that, like, I don't know, Objective-C is just really bad at strings. I mean, it's very good. When I go to other languages and I see their string libraries, I feel better about Objective-C's string library, but Swift's is like, whoa. They're awesome. They're Swift struct, which is really an implementation detail, but it means you can do some really cool things we'll see later. And it handles the double byte Unicode characters, code points and all that stuff that I don't really understand. It just does it for us. It's nice. And what's even better is that you can have, you know, these are both functions that are in a code base I've written in production, and you can have non-ASCII characters be function names. You can have emoji be a function name. If you're in a Russian-speaking country, you can have Cyrillic characters, Japanese, whatever you want. It all works. Really cool stuff. Is this nice for searching the code? These are both sort of extras, like bonuses. So I don't actually use these methods. The question was, you know, like, do I actually use them essentially? No, they're just in there for fun. But you could, if you wanted to, you could have like the smiling poop emoji be like the assert no or something like that. Who knows? Anything you want. Yeah. So the next criteria was native collections. Collections in Swift are structs. They're generics, actually, which is really cool. Bridgeable to Objective-C equivalents. That's really nice. Very concise syntax. There's an optional like full syntax, but they actually do have language level support for creating these really easily. I like it. Next criteria, be concise. This is really subjective. I mean, coming from an Objective-C background, anything is concise. I don't know if anyone's ever looked at Objective-C, but it's like this long. It sort of follows the standard way of using technologies that Apple releases. Simple things are easy, difficult things are possible. And yeah. Final requisite was named parameters. Sort of optional. The compiler does funny things for Objective-C interoperability. All works. I like it. Quick example, we've got a function called compare. Takes a left-hand side, which is a string, and takes a right-hand side, which is another string. But when you're calling the function, we use the to label for the parameter name, but inside the function, we use the RHS label. So when you invoke the function, it's compare hi to hello. It's nice. I like it. Writing Swift is pretty great, I think, mostly. There's a caveat. When you write Swift, if all you're doing is writing Objective-C with Swift syntax, then you're really losing out. Like, that is a huge missed opportunity of just, you could be writing things that are safer and faster for you to make. And if you're just using Objective-C with Swift syntax, I don't know, that's a shame. Generics are one of the biggest things that we wanted in Swift. We got them. Objective-C is very dynamically typed, and Swift is statically typed. And that's a huge transition, trying to get developers from thinking in a dynamic way into a static way. I like it. It's pretty awesome, mostly. You get compile time type safety, which is something that no one in Objective-C ever thinks of because it's C, so you can just basically cast to a void star pointer, and who knows what it is. Objective-C distinguishes between primitives and classes, and Swift doesn't care. It's actually really, really nice. This means that if you wanted to have an array of integers in Objective-C, you would need to do one of two things. You either need to use a C array, malloc and free it yourself, which is terrible, or you have to box your integers inside of a class. And that's also not that great. So strings, arrays, dictionaries, all use, well, strings don't use generics. Arrays and dictionaries use generics. Strings is struct. That's a typo. Okay, so let's take a look at making your own generic. I apologize for people in the back, might not be able to see this. It is a very simple stack implementation using a struct in Swift. We have a content, it's an array of something. When you push a new value, we get a value of that type of the array, and we pop it on the end, or push it on the end. When we want to pop, we remove the first item from the array and return it. And we have a computer property that just returns if the number of elements in the array is 0, then the stack is empty. Creating it and using the stack is really, really easy. At the top, we have a stack of integers. Underneath that, we have a stack of strings. Underneath that, we have a stack of stacks. Using it is really cool. And I know this is like old hat to a lot of like C# developers. I started in C# and I still miss it. LANC is like so cool. Maybe we'll get it someday for Swift. Anyway, I love generics in Swift. Swift also has language level support for lazy evaluation. This is really cool. If you have a global variable, it's applied automatically for you. It's only created the first time you actually access that variable. It can be applied to any property. And if we look at an example, that class has a lazy property called name. It's my name. If we create a new instance of the class and call the name property on it, it returns that lazy assignment. And only when I call the name property does the property get assigned to the value. But if we create an instance and then give it a different name, then when we access it after that, it's been replaced by the new name. So you can actually supersede the lazy property by assigning it before you read from it the first time. So that's pretty cool. You actually get something else really cool besides just overriding the setting before the first access. You do this really cool trick with closures. If we have a similar class, but I've created a lazy property called greeting. It's a string, and it is equal to the value returned from a closure that is executed the first time that the greeting is accessed. So let me say that again. The first time we access greeting, the closure that's assigned to the value is going to be executed. That's what the parentheses here indicate. And whatever value the closure returns is going to be the value set to greeting. And the use is very similar here. Just like before, it returns the default. If I create an instance and change its name before I access the greeting, then it's going to return hello Orta. But if I change the name to Alloy, then when I go to access the greeting, it's already been set to Orta. Changing the name property doesn't mean anything because we've already assigned the greeting property to something. Something else that I really like in Swift is the idea of extending types. Objective-C has the idea of categories that you can use to extend classes. Swift has extensions that can work on anything. Structs, primitives, which are structs, classes, enumerations, anything. So a very, very quick example. I have an extension of integer. It has an hours property, just returns a time interval That's whatever the integer is times 3600, number of seconds in an hour. Then we have an extension on time intervals, and we say from now or ago, and we use some date math. So now we can type in 4.hours.from now, and we'll get a date that is 4 hours from now. Very like Ruby-esque syntax, and I love that this kind of thing is possible. Index paths are kind of weird. They're really, I haven't seen an equivalent data structure to them in other languages, used in the same way anyway. They're used to identify cells in a table view, so anything you're scrolling, list of your music, settings, emails, that kind of thing. Basically, we divide the table view up into sections. Each section has a number of rows, and you need to configure that cell. You need to respond to the cell when it's tapped, all that stuff. And you get a lot of really terrible code. And the code looks like this. And I hate it so much. I hate writing this, I hate reading this. There are things you can do with like constants to make it a little bit more readable, but the structure of the code is always going to be the same. I really hate it. It really makes me want to scream. And Swift has something that's a little better. You can create a tuple based on the section and row, and then you can have case statements. So we basically flattened out the indentation a little bit, which is better. You know, is it better? No, it's not really better, because the structure is the same. You still have this like divided out, you know, garbage, and for every single different type of, every different cell that's possible in table view, you need to have one of these case statements, which is terrible. So instead we can do something like this, and this is really cool. Same switch statement, creating a tuple with section and row. The first case, we're saying for the first section, any row, bind whatever the row is to a new variable just for that case. Later on, we have any section where the section mod 2 is 1, so any odd section, and if it's the first row. So the first row of odd sections, that's really expressive and powerful. We even have the ability to call a validate function, so if there's a specific type of section that we're looking for based on the current state of the table view, we can do that, and then we have a default for all other cases. So this is like, you wouldn't actually use all of these case statements in the same table view. That would be ridiculous. But the fact is that there is a lot of possibilities that you can explore with this. So is this better? Maybe. I don't really know. I like it better, but again, that's subjective. I think that we need to look for new ways to solve familiar problems. And this is something that I preach to the iOS community, and they're really tired of hearing it, to be honest. Just because we did something a certain way in Objective-C doesn't mean that we need to continue to do it in Swift. And something that I want to do is explore. I want to expand out in all directions, and we've seen a lot of Swift open source projects do this, which I'm so excited to see. Try new things, and some of them don't work, so we abandon that and then try and go in the other direction, because that actually does work. We're not going to know if something works or not unless we try it. Something else that's really important is to ask other communities how they solve problems, because you know, C# has a way of solving problems. Ruby has a different way. Every different language has its own unique way to solve problems, and I want to explore and grab the best ideas of the other communities and bring them back to Swift. So that's a lot of roundabout in order to get to the big question, how to use Swift in production, whether or not you should. That's what the talk is actually about after all. So I mentioned earlier, I work for a company called Artsy. We're basically Pandora, but for art. So we have a recommendation engine that gives you recommended artworks based on your likes and dislikes. And yeah, we, as part of our business, we developed a bidding kiosk for benefit auctions. So patrons can go up to these things. It's basically an iPad inside of an enclosure. And they tap on the artwork, they enter in their phone number, they swipe their credit card, and they've bid on the artwork. And that was a really exciting project for me, and I was the one in charge of heading this up. And something we wanted to try on the mobile side is the idea of open source by default. We decided to develop the application in the open because there was no reason not to. No one is going to steal our code and make their own auctions application, because the application we made is so intrinsic to our API that it would be easier for them just to start over and write their own. And it was really helpful in asking for help from others, especially at Apple. You know, if we found a compiler bug, which we found a few of, we'd just be able to send them our code and just be like, this is the commit that was breaking on GitHub. Here you go. And it was fantastic. If you'd like to check out the code or look at any of our issues, or if you have a question, you can open up your own issue, github.com/artsy/eidolon. So to give you a basic time frame of this, August, we're starting to start development. Swift had been out for 2 months. Stability, way better than it was when it first came out. Swift seemed ready to use in production. And it wasn't. It wasn't at all. So September came around. We've been working on it for a few weeks. The language was fantastic. Lots of frustration with the tools. Xcode, which is the IDE for developing iOS applications, constantly crash. There's a really terrible crash that would happen. It's not even a crash in the IDE. They had separated out the syntax highlighting from the actual IDE, so they're in separate processes, and the syntax highlighting process would crash like 12 times in a second, and then like go for another like 10 seconds, and then crash 12 times again. So you get this like flickering notification that SourceKit had crashed. All of your syntax highlighting goes away, and the keyboard commands to navigate between your code no longer work for about 2 seconds. And it's really frustrating. Yeah. Third-party tools, we were used to using CocoaPods. My boss, Orta, is one of the 2 heads of CocoaPods right now, and CocoaPods didn't work with Swift yet. So that was a big change for us because we're used to managing our dependencies on CocoaPods. Now we're using Git submodules, which is a nightmare. Third-party tools weren't ready or didn't exist. Eidolon was used as a test case for CocoaPod Swift support, still is, when new features come out. We built a lot of tools. One of them is used to hide things like API tokens that you want to keep secret, but you want to have an open source project, so where do those go? So we built a tool. It's actually CocoaPod's plugin that does that for you. Other tools like unit testing libraries, we use one called Quick. I've been contributing back to it, documentation fixes, feature requests, bug reports, bug fixes, pull requests, all that kind of stuff. So it's pretty good. So then October happened. We're running way behind schedule. We have a hard deadline now. We have a benefit auction that we promised them. This kiosk is going to be part of your auction, and it's not ready. We explored some ways to speed up development. Could we just throw up a web view that would fall back to our existing web app? Sort of. I mean, it would work, but it wouldn't work. It was just going to be more hassle than it was just to continue with the Swift. We even brought on another iOS developer at Artsy to try and help us finish on time. Orta sent out this email to the company, which is a really awkward email to send out. We don't expect to meet our deadline. And that was a really sad day, because I was remote at that point, and I'm 6 time zones away from New York, and you know that was really demoralizing. But we put our heads down, and we did in fact make our deadline, which is an exciting thing to do when you've been working on a project for 4 months. Unfortunately, it led to burnout. All 3 of us were very, very not excited about programming anymore. This happens when you work long hours on a project for weeks at a time. And not only did we have burnout on the personal level, our code wasn't great. We had to abandon unit testing our new code about 2 weeks away from the deadline. So we accrued a significant amount of technical debt. We've almost finished paying it back now, and we finished the code base like late October. And it's been a lot of effort to try and correct those mistakes, and in order to and a lot of effort to make the code base something that it's easy to add new features to, and it's not going to break or crash or anything. Some problem-solving techniques we used. I use the word techniques very loosely. Compiler optimizations were seg-faulting the Swift compiler, so we disabled optimizations. The app then became too slow to run on the hardware that we had purchased for the kiosks, so we bought faster iPads. The tools didn't exist to do certain things that we wanted to do, so we built them. Today, Swift is a lot better. Swift is not this unstable monster that is going to destroy your productivity, burn out your team, and give you a lot of technical debt. However, it's still very hands-on. It's a new language. There are going to be bumps and wrinkles, and just generally, it's not unlikely that you'll come across a problem that no one else has come across before, and you're going to be the first person in the world to experience this edge case. And that's exciting to me, but it's also terrifying because I don't want to have to, be behind on my schedule to deal with that. But it's awesome. I go back to writing Objective-C on our other two code bases, and I miss Swift. I really do. So yeah, it's awesome, but it sucks. Where is it going? This is kind of a big question. Everyone asks about this, like, where do you think the future of Swift is? Well, there's some safe bets. The tools are going to continue to improve. Apple tools are always a year away from being stable. I don't know if there's like a Java or a Microsoft equivalent to this adage, but yeah. So I mean, this summer we'll see probably a big update to Swift at Apple's Worldwide Developer Conference. I'll probably wait a few months before I start to use it. Yeah. The language is still going to be awesome, and it's going to get even more awesome. They've had point releases of the language over the past 6 months or so that add some really cool features that I'm really excited about, that improve the interoperability with the existing Objective-C APIs, that have fixed 99% of the stability issues with Xcode and SourceKit crashes and the compiler seg faults, and all of that stuff that I told you about that was really bad, like 99% of it's fixed. So yeah, I'm just following that trend line. I think it's going to continue to improve. Some less safe predictions. I think we're going to see more functional APIs from Apple. I didn't really go into some of the ways that Swift encourages functional programming that Objective-C didn't, but it does do that. I think we're going to see more functional APIs from the community. I'm a huge fan of Reactive Cocoa. Reactive Cocoa is currently being, it's very close to a 3.0 release. It's on Alpha 3 now, I think. And basically it's a functional reactive library for iOS, but now it has first-class support for Swift, which is fantastic. And I don't think we're going to see any Swift-only APIs from Apple. I don't think iOS 9 is going to come out and there's going to be a new feature that developers are going to want to use, but they're going to have to use Swift in order to use it. I just don't see it. I ran into Chris Parker, who's basically like, I don't know, what is his title? It's like iOS UI Kit Evangelist or something. Anyway, he's one of the head guys at the UI Kit team in Apple, and I ran into him on the street a couple of days after the announcement of Swift, and I said hi, because I follow him on Instagram, and his dog is adorable, and I just want to tell him that. And he asked what I thought about Swift, and I said it looks really cool, and I'm really excited about it, and he cautioned, he said, don't worry, Objective-C is not going away anytime soon, and that kind of made me sad, and I told him so, because I want it gone, and I don't think it's going to happen. Apple is way too worried about disenfranchising the first and second wave of iOS developers. So let's go over a quick recap. We talked about why Swift was needed, given the legacy and the history of Objective-C. We talked about how Swift met most of those needs pretty well, in my opinion. Talked about how writing Swift is pretty awesome. I really enjoy it. It's a fun language to use. Using Swift in production back in August is a terrible idea. If you're not in August of 2014, then writing Swift probably be a good idea. My friend Dan says that every line of Objective-C written from now on is legacy code, and I like that. I like that quote a lot. And finally, we discussed some of the future predictions of Swift, where it's going to go, what we're going to see from the community and from Apple. And if I had to go back and do it over again, it was a bad idea to use Swift so early. It wasn't even out of beta yet when we started to use it, which was fine for us because we were doing enterprise distribution, not the App Store, so we could use the betas. But it wasn't a very good idea. Now I think it's a much stronger case. But every different developer and every developer team is going to be responsible for making their own informed decision. So with that, I'll leave that up to you. Thank you very much. I think we have time for questions.
I have a question. If you have like a developer that's not familiar with Objective-C yet, but wants to get into iOS development, would you recommend just jumping straight into Swift, or do you think then that would just require you to essentially learn both Swift and Objective-C at the same time?
There's been a lot of debate over that question in the iOS community since the announcement of Swift. There's two sides to that. So the first one is that Swift is going to be a lot easier for them to approach. The tools are much easier for them to use. Learning tools are a lot easier to use. But Objective-C has a lot more resources available for learning it around the web. The problem with that argument, in my opinion, is that a lot of the resources for learning Objective-C are for learning Objective-C in 2012, 2010. It's a different language than it is now. Writing modern Objective-C, there are some tools out there, but as a beginner, trying to distinguish between what's good Objective-C and what's bad Objective-C when they're just trying to learn, pretty difficult. So I would recommend using Swift. In fact, the bottom URL is a book that I'm currently writing, if anyone's interested.
So two quick questions.
Sure.
What's the adoption rate among like major iOS developers and or Apple in their apps?
That's a really good question. As far as Apple goes, we don't know. They don't release it. If I had to guess, the first app that they're going to develop in Swift is going to be Xcode, because Xcode is like the guinea pig for all of Apple's new programming technologies. It was the first one to use automatic reference counting. It was the first one to use garbage collection before that. I'd be really mad if I were Apple. If I worked on Xcode and they're like, hey, you got to use this new garbage collection thing. And I spent months like doing that. And then they're like, hey, garbage collection is deprecated. You got to use Arc now. I think when we see them announce that iTunes is written in Swift, that'll be like the canary in the coal mine for Objective-C. Like it's over at that point. As far as adoption in the community, it's really mixed. A lot of Objective-C developers don't want to switch, but most of them have admitted the inevitability of having to switch. That doesn't mean they're going to do it anytime soon. They just recognize that they're going to have to eventually. A lot of developers really want to use it, but there's like their one thing that they want to do. Like you still can't have, or no, they fixed this in the last release. You can't have generics in a separate framework that you use. They have to be in the same framework as you use them, which is really weird. So we're seeing most of the reasons not to use Swift be addressed. I don't have specific numbers. 90%-ish of the developers have played with it and are excited about it. And most of them would like to use it in production code. Most of the ones who aren't are probably not doing it because their bosses won't let them.
And my other question is, sure, as a Java developer, what would be my experience if I started coding in Swift? Like, what are a lot of the big differences, I would say?
Sure. So one of the big differences is with the learning tools. Swift introduces two things that are really interesting. The first is a REPL, which is a redeveloped print loop. You can invoke it from the terminal window, and basically you get to type in Swift commands, play with it, very similar to like Clojure if you've dealt with that before. More user-friendly is the Xcode playgrounds, which are basically a window, and you have text on this side, and you've got results on this side. And you type Swift over here, and you see in real time the results of your Swift code, and you get compile errors and things like that when they happen. And you can actually do a lot of really cool things in playgrounds, just literally playing around and learning the syntax and deciding on whether or not you like it, figuring out how things are similar and different. I honestly think that playgrounds are one of the biggest benefits to Swift in terms of teaching and learning it, just because they're really easy. They are a really easy way to approach learning the language. As far as like syntax goes between Java and Swift, I haven't done Java since like 2008, so I don't know what the current state of Java is. You know, Swift is like Apple's trying to catch up to the existing state of the art, and that includes Java and C# and Ruby. So I think that you'll probably find some things that are familiar to you, especially like generics, which Swift just got. Java's had them for a while, I believe. I don't know, to be honest.
So I think one of the things that a lot of people were disappointed wasn't in Swift was some kind of native concurrency support, or like, you know, support for more advanced concurrency features that you see in other languages. Mm-hmm. So I'm wondering if you think that's like something that will appear in a Swift 2.0, or do you think that GCD, Grand Central Dispatch, is like Apple's way forward for handling concurrency with developing iOS apps?
It's interesting because Grand Central Dispatch came out for the Mac in 2009, which is before they started on Swift. So I definitely think GCD is more of like a Objective-C approach to things. It's even like using it in Swift isn't the prettiest syntax. I'm encouraged by Swift's use of encouragement of using constants instead of variables. So you use let to declare something instead of var to declare it. Let means that you can't mutate it, and if it's a struct, then you can't call any functions on it that are mutating functions. So the struct example that I showed earlier, if you declare a struct with let, you can never change it. It will always be an empty struct. I think that's pretty encouraging for the idea of some sort of language level concurrency. I wouldn't be surprised at all if we see something like that, especially given the number of cores on iOS devices nowadays. And you know, Grand Central Dispatch has proven to be good. It's more like something that you can shoot yourself in the foot with if you do it wrong. So if we could get something a little higher level abstraction on top of that, even on top of, like, it's like there's POSIX threads, and then there's GCD, and there's like NS operation queue. If we have something like better that has like first class support for concurrency, yeah, I think that's not unlikely.
Cool, thanks.
Yeah.
So coming from different languages which are more matured, there's constantly a need of maintaining quality of a team's code, essentially. Like, there are a lot of these linting tools available for different languages. However, in Swift, obviously the documentation for the compilers and are not exposed to open source community. Mm-hmm. How do you think the need for any linting tools or any quality measurement tools for Swift language is a necessity, and ever-growing necessity, and is it going to come in any time future?
Yeah, so we've seen Apple increase their commitment to unit testing, which is, I don't know, I still don't think that they're doing enough to encourage it and to make it easy for iOS developers to actually test their code. And they haven't released something like, the Swift compiler will actually do abstract syntax tree construction of like your code comments if you format them in a specific way. And it would be really great to see Apple release some sort of tools to do that. I don't know if they will, though, but there are some community tools to do so, like the one for actually dealing with abstract Swift syntax trees is called SourceKitten, which is pretty fun, and I think there's some other ones. I really hope we see some code coverage reporting tools. That would be fantastic. Ideally, Apple would just open source the whole compiler, and I don't know. I'm thinking that that's more and more likely every day. Not that like every day that goes forward. I think that it is slightly more likely than I thought it was yesterday. So hopefully, does that answer your question?
Yeah.
Okay, cool.
Do you know of any publications like iOS Swift for Android developers?
iOS Swift for Android developers. I don't know of any.
I'm looking for something for solid Android developers to transition over to Swift and iOS.
That'd be a really interesting book. or resource or whatever it is. I don't know of anything off the top of my head. Sorry.
So I come from a C# background, and I mean, a memory management is kind of a feature of the framework. Right? It's given as long as you don't have a transient object connecting to a global object, you're good, so that you don't hold on to any leaks. I'm a little confused how a removal of a garbage collector is a plus, and you showed it in your slide as well, for any kind of programming language or a framework.
That's a really good question. It's not something that is strictly better or worse. It is something that's different, and it has pros and cons. And I tried to, like, my pros for that are that it's familiar and stable, which is not saying that is better than a garbage collector. Arc is really, I have a love-hate relationship with it because it forces developers, and this is particularly difficult for beginners, to infer where there might be reference cycles between their objects and deal with those in the code by saying to Arc that this is a weak relationship and it shouldn't be, the cycle is broken by this relationship. That's very difficult to teach to developers. And it's a lot of cognitive overhead. I would prefer if we didn't have to deal with that and Swift was just garbage collected and it was completely memory managed for me. I would like that. I see the reasons why Apple didn't do it that way. And I maybe someday we'll see it. Apple seems to have doubled down on the Arc way of doing things, so I don't know if it's very likely anytime soon. Does that answer your question?
Yeah, it does. My only concern is it might make it difficult for people who work with C# or Java, where memory management is kind of by default, to transition to something where it's a pretty big thing, memory management. It's,
Yeah, I definitely share your concerns.
it's on the top 3-4 things like performance, good code,
Totally.
So I just want to respond to that question. I think the other thing is it's great for battery life, for the devices.
Yeah.
For performance in general, it's definitely a good thing. And although you do have reference cycles, I don't think it's that big of a deal.
Yeah, it's definitely like something that there's no like right or wrong answer on. As I said earlier, like there are pros and cons. One of the other pro I listed was that you don't have garbage collection overhead, which on a device that is CPU constrained is a really big deal, because then you don't get the UI like freezing for, even freezing for 50, 100 milliseconds would be noticeable if the user is scrolling at the time or watching a video or something. If the UI freezes for that long, then that's a problem. But I did say earlier that hardware continues to get faster, performance increases, but our ability to understand complexity doesn't. So I think in the long run, whether that's like 2016 or 2060, like if iOS is still around, then I hope that it's not using Arc, because ideally we'll all be running quantum computers and they can deal with garbage collection overhead. Is that?
Yeah, but as long as we get different batteries.
Yeah, well, that's the other thing. It's not just exactly. It's not just the processing power. It's not just the memory, like available RAM. It's also the power. And if Apple would stop making these even thinner and actually like keep them the same thickness and just like add more battery, I don't understand what the problem is with that. But yeah.
And my other question is, do you know if like one problem with Swift is great, obviously, if you're developing for Apple, but like all Apple, like Objective-C, for instance, you could at least develop it on Next as well. You still could use GNU-Step, for instance, and develop Objective-C. So, for instance, a Linux developer, so I learned Objective-C through GNU Step. But Swift, you pretty much have to own a Mac.
Yeah.
Do you think that they will open up the language, or possibly there will be open source compilers, so Swift can be used on other platforms?
There was an open source compiler I saw a few months ago. I don't remember, something really weird, like it cross-compiled to JavaScript or something weird. So I think the likelihood of compilers coming from the open source community, pretty high. Ideally, we'd see a Swift compiler released from Apple that's open source, and then you could actually run that on whatever system you wanted to. I don't see Apple releasing like Xcode for Linux or Xcode for Windows anytime soon. It's just not, like, there's this joke, and it probably has some truth to it in the iOS world, that we only have Xcode because Apple needs Xcode to write their own apps. And you know, if they didn't need Xcode, then there would be no Xcode. And we'd just be using, you know, Vim and Makefiles. So yeah, unless Apple needs Xcode for Windows or Linux, probably not going to see it. But I hope that they release the open source, that they open source the compiler, and maybe we'll see Swifts on the web server, or, you know, Swift on, you know, I don't know, doing interesting things in, I don't know, number crunching or something, right? Like, there are other applications for this language beyond just running, you know, fart app games, and I'd like to see us explore that. Any other questions? All right, thank you very much. You've been a great audience.